Hello, we are group Urban number 5. I am Riley Hosner.
I'm Alejandra Reese.
I'm Charlie Ma.
And we are showing you our GUI project today. This is what our GUI looks like. The GUI is complete with solar panels, wind turbine panels, an axis for the image, save buttons, a bill of material button, and wind and solar power estimate buttons. The GUI is user-friendly because it contains static boxes which guide the user on how to use the GUI. These are the static boxes that guide them. And there's the 3 cities that were coded in with a grid to display. And these are the panels which you can select what kind of solar panel you want to use and place it on the GUI. And these are the wind panels that you could select to use on the GUI as well.
Okay, so for task number 3 and 4, what we want to accomplish is to allow the user to select whichever solar panel like this and how you actually place it onto the image, filling that grid spot representing that particular solar or wind turbine. So let me do it for a couple of more times and show you how it works. So as you can see, the colors are being filled to that particular grid box which the user pressed on. Okay, so another thing to notice is that if the user clicks anywhere but in the image, that color box does not appear, which is important for calculations for estimating potential solar power and wind power. So if you want to have a quick look at the code, just explain a couple few things. We're going to go to our callback function, which is a pop-up menu 3. So as you see, the get input actually just gets the x coordinates of where the user clicked, and the first if statement is where the position of the axis is, and so if it clicks anywhere besides that, it won't go through the code below it. It's a limit. So what this code does is it selects it gets a string where the user selected it from. So after that is done, what this part of the code does is that it colors that particular box into whatever color you want it to be, which is defined by this function here. And then it displays the image by this. Okay, and so now we're gonna go on to task number 6 and 7 and how that works.
So in task 6 and 7, they are similar to each other, so I'm just going to explain task 6. So first we calculated the size of each box in the grid, which is 54.7 by 54.7 feet. In the code, we set box size equal to 54.7 times 54.7. So next, we calculate the area that is occupied by each of the solar panel and wind turbine. For each solar panel, since the dimension is given by length times width times height, we took the 2 largest dimension in order to get the occupied area. For the wind turbine, since the diameter is already given, the area that is occupied by the wind turbine can be easily calculated. After calculating the area, we calculated how many panels and turbines can be placed in each box on the grid. At the end of part 6 and 7, we put all of our calculation in if else and switch case statements for users to select and find out what the estimate solar panels and solar powers and wind powers are, as shown.
So that's the estimated potential solar power and estimated potential wind power.
Okay, so now we're gonna go on to task number 8, and so what that does is task number.
So for task number 5, there were three different things that we needed to do. We needed to find a way to save the image as an image and then also save it as a text file, and then come up with a bill of materials. For example, if you go to the Save button, this shows that the file is saved in a file name and then read out and saves the file. So if you go back to the GUI, we could save the image. And save it as a PNG.
And this actually instructs the user to name it as whatever they would like. So they can name it Google, they can name it anything they'd like, but it has to be a PNG file. And you click save, and if it already exists, yeah, it's fine. So you put yes, and then you should be able to access it again once you click out of the GUI and rerun it again.
And you can also continue on the saved work. The button for the continue on the saved work can be shown right here, and it includes the grid, which allows it to be placed on the image as well, so that both the grid shows and it fits to the right dimensions that it was previously shown, which is given by this. So, and then if you go back to the GUI, there's a bill of materials that is made. So there's only one dot there, so I'm going to actually put a couple more. Okay, so in here you can look at the BOM text and it'll tell you how much everything costs. To do this, multiple if-then statements were used. The user can click a certain panel or turbine of their choice to be placed on the grid. If the user clicks and uses a certain panel or turbine on the access grid, it will be assigned to handles and display one true for field. Once it is determined that the user has placed the panels or turbines on the grid, the amount of times it has been added to the grid will be multiplied by the monetary value. If a turbine panel is not selected for use, 0, false, will be displayed. The variable will be assigned a 0 for no charge. The text file is created using an fopen function. I'll show you that right now. Oops. Over here. Here's the BOM. Okay. The file is used an fopen function and assigned to the variable JAWS. An fprintf is used to write on the text file the name and type of each solar panel and wind turbine and the cost of each if used. Fprintf function %s is used to substitute for the string array, and %4.2f is used to show the price of the objects with a decimal place in the hundredths. The function type is used to display the bill of materials on the command window.
Okay, so now what this does is actually saved it onto a text file. So for task number A, what you want to do is actually retrieve this text file and open it up in a GUI again into an image to allow the user to use a previously saved text file and continue working with this. So I'm going to show you a quick overview of the code really quickly. So if you scroll down to the very bottom, what this does is the first line reads the text file. It makes it into a matrix. This part right here actually converts the matrix into a readable 3D image that is displayed. And this part here is just the grid that we mentioned earlier. Okay, so now we're going to give you a brief overview of how everything works together. So if we rerun this code, you can click on any city you'd like. There's Birmingham, there's Anchorage, and there's Little Rock. And Here, let's click whichever solar panel you'd like, any wind power you'd like. Then after this, you can create a bill of materials, and it should pop up here in the command window. And you go here, see all the prices are 0 because we only clicked certain panels. Then you go back to your GUI, and you can estimate the power, as you can see here. You can save the image, which is going to pop up right now. And make sure you can name it anything you want, but make sure you save the image as a PNG image. You put yes. Okay. Now what I want to show you is that I'm going to click out, and that the saved image that we just did actually does reopen. So allowing the user to keep working on it. So you go here, and as you can see, it is working.
Thank you.